In this video, I want to have a look at solving simultaneous equations. Previously, we've looked at solving them graphically, so by drawing both the straight lines and reading off the point of intersection, but it's not always very accurate doing it that way. So what we're going to do instead is we're going to have a look at two algebraic methods of solving them. One is substitution, and that's what we'll look at in this video, and in another video we'll have a look at the elimination method. The first example that I want to have a look at is this one. So we've got our two equations. We've got y equals 4x minus 7 and we've got y equals 2x plus 1. And we want to find the values of x and y that satisfy both of those equations. So the first thing you always want to do when you're solving simultaneous equations is label them equations 1 and equation 2. So that way we can refer back to them. So the idea with the substitution method is that if we know that y is equal to 4x minus 7, and we also know that y is equal to 2x plus 1, then that means that these two things have to be equal to each other. So what we're going to do is we're going to take one of the equations and substitute it into the other one. So for example, if we sub equation 1 into 2, and you're always going to write down what it is that you're doing so that whoever else looks at it knows, and so you keep track of what you're doing as well. So we know that y is equal to 4x minus 7. If we substitute that into equation 2, that means that instead of writing this y, we're going to write 4x minus 7. So we're going to have 4x minus 7 is equal to 2x plus 1. Alright, so now we've got one equation and it only has x's in it. So when we don't have two variables anymore, we only have one. So we know how to solve this now. So the first thing we want to do is get all our x's on one side of the equation. So we'll subtract 2x from both sides. And we'll end up with 2x minus 7 is equal to just that 1 left over here. And then we'll have add 7 to both sides. So we'll have 2x is equal to 8. And to get the x on its own, we'll divide both sides by 2. We'll end up with x is equal to 4. So that's half of our answer. That tells us what value of x makes these true, but we also need to find the value of y. So we're going to use that x equals 4 now. I'm going to substitute it back into one of our equations. So sub into, it doesn't matter which one we do, maybe question 2 because it has addition, equation 2 because it has addition, and sometimes that's a little bit nicer to work with. So then we'll have y is equal to 2x, but x is 4, so it's going to be 2 times 4 plus 1, which would give us 8 plus 1 is 9. So the final solution to that simultaneous equation is x equals 4, y equals 9. And it's always a good idea right at the end to go back and substitute those values into both of the equations and check that it works. So the second example I want to have a look at, our equations are 2x plus 3y equals 16 and x equals y plus 3. So again, the first thing you always want to do is number your equations, so equation 1 and equation 2. Now in this one, we know that x is equal to y plus 3, so we can substitute that into our first equation. So where it's got x, we can replace that with y plus 3. So the reason we're doing it that way is because this x is the subject of the equation, so it's given to us on its own. So we're going to sub equation 2 into equation 1. So we'll have 2x, but x is y plus 3, so it's 2 times y plus 3, plus 3y equals 16. Okay, so expanding that bracket out, 2 times y is 2y, 2 times 3 is 6, so plus 6, then we've got our plus 3y equals 16. Then we can simplify this bit, so 2y plus 3y will give us 5y, plus 6 is equal to 16. Then we're going to subtract 6 from both sides and end up with 5y is equal to 10. And then we'll divide both sides by 5 to get that y on its own. And we'll end up with y equals 2. So again, that's half of our solution. We know what y is. We need to figure out what x is. So we're going to substitute that back into one of our equations. Again, it doesn't matter which one you substitute into, but in this one, equation 2 will be a little bit easier just because x is already the subject. If we substitute it into equation 1, we'll have to rearrange it. So let's substitute into equation 2. So we'll have x is equal to y plus 3, but y is 2, so it'll be 2 plus 3 is equal to 5. So our equation, so our solution is x equals 5, y equals 2. So that's 2 examples of how to solve simultaneous equations using the substitution method.